we have a new dialogue about a seductive book. We are together with an excellent author and an extraordinary scientist. Our guest wrote Genesis, the ultimate story of the origin. Thank you, Mr. Guido Tonelli, for the privilege to be together. Thank you very much.
Thanks to you. It's a great opportunity.
Thank you very much. Please let me start with this question. A quote: "We desperately need poetry. La poesia ci serve disperatamente." Is the first motto, your motto you have chosen to introduce your book. Do we need poetry also for understanding the great story, the ultimate story of the origin?
It's a very good question, and I think is particularly fit with the particular moment in which we are making this interview, because we are coming out from a terrible pandemic era, and we are in an era in which the war in Europe is again at the center of the stage. So everybody is full of worries and full of fears. And I'm pretty sure that in these moments, poetry means the beauty in general, you know, is like a synonym of beauty. And sometimes people ask, what is the real need of art and beauty for human beings? And my answer is, we need beauty, we need art, we need poetry, particularly in the moment in which we have difficult times. Our story, the story of our species, is a story of disasters. So we are here, heirs of a long story dating back hundreds of thousands of years, in which our ancestors were exposed to terrible tragedies. And in this story, they developed tools to survive. And one of the most important tools to survive is our image of the world. The idea we have of the scenario in which we are living, the universe, our planet, the story in which we are embedded, all this requires an explanation. And since the old times, mankind has tried explanations that were mythical explanations at the beginning, religious explanations. There were stories that were told to our ancestors, stories that are needed to survive, to give a sense to what we are living, in particular during the tragedies. And the reason why we are here today is because we are the heirs of these old ancestors that tried to find stories to explain what is happening. These stories have become science. Now we have a clear explanation of what is happening around us. This story has become poetry, has become art. We have the beauty of the artistic production, which give us relief and sense. This is the sense of the quote. Particularly in the difficult moments, those are the moments in which we have to recall ourselves, what we are doing here, what is our purpose, and we have desperately needing the beauty to survive.
Is the poetry narrative in relation to complementarity, or is in relation of contradiction with scientific narrative about, let's say, the ultimate Genesis?
Yeah, there are connections, because the scientific story of our universe is beautiful. Because the concepts that are used in modern science are extremely nice, are creative. They bring us to the edge of knowledge. So there is inside science, in terms of scientific concept, something really marvelous that looks like a piece of art, no? But on the other hand, art in itself has an autonomy, as its own field of development. So the beauty of an artistic, of a sculpture, or of a picture, of a piece of theater, of a ballet, of an opera, of a music, of a poetry, is something that has nothing to do with science. In some sense, adds something to science. In some sense, science helps us in exploring the external world, no? The world surrounding us. While arts and beauty allows us to understand what is inside us. Science explores the natural world. Arts explore our internal world, which is infinite, which is immense, full of emotions, full of intriguing issues. And so there are two complementary fields, in my view.
Mm-hmm. As a scientist, are you some kind of Ulysses or Odysseus?
I think behind each scientist there is this mythical figure, no, of the person which is wandering, looking for new people, new beaches, new islands. But meanwhile, we are doing this. This is the same today. The physicists. We have not the ships of Odysseus. Our ships are incredibly complex infrastructure, scientific infrastructure, being the LHC, the Large Accelerator of Geneva, or the big instruments like CMS and Atlas, which are like cathedral, like building of 4 or 5 stories full of technologies, or a big telescope with which the astronomers look into the sky. No? Those are incredibly complex infrastructure. But they are like the ships of Ulysses, because with this infrastructure, we make trips. We make trips into the tiniest objects, the smallest structure of matter. This is what high-energy particle physics do. They use the accelerator to explore, to make a trip into the tiniest dimensions, or the telescopes in which astronomers and astrophysicists, they explore the largest possible dimension. So in some sense, we are both on ships, special ships that allows us to explore an unknown world. No, we are looking, we are trying to explore this new world in which, and we are the first one to explore them. But we are similar to Ulysses, to Odysseus, in another sense. Remember that in the Homer work, Odysseus is continuously nostalgic, no? Nostos. He wants to come back. He wandered for the Mediterranean Sea, but he always dreams of his small island, Ithaca, with his wife, Penelope, with his son, Telemaco, with this bed built in an olive tree, with the dog which is waiting him, the old father. He wants to raise olives and to eat the cheese, homemade. All this is nostos, no? Also, the modern scientists, we want to come back home. Once we explore this new world, we would like to build theories. For us, coming back home, meaning we have explored this world and now we have a better picture of the world. So we build a new theory of reality, of nature, and this theory incorporates what we have discovered in these trips. So in some sense, it's like coming back home, ready for another trip, for another scientific adventure.
Mm-hmm. Actually, the next question of mine is exactly this. What is the Ithaca for the scientist?
That's a very good question. Basically, it's very strange because people don't realize that, so the prejudice that there is on scientists is that we want to prove our theories or theory. So we make experiments because we are eager to prove that our vision of the world is correct, no? Mm-hmm. While it is actually the opposite. So the real will inside each true scientist is to find something completely unexpected that will produce a complete disaster in the current understanding. And we had to rethink everything from scratch. This is the dream of every scientist. It doesn't happen frequently. Most of the cases we prove that the current theories are correct. But at the moment in which we discover something completely unexpected, we have to build a new theory that incorporates the old theory as a special case. No? This, for example, was the case of, say, the gravitation view by Einstein, incorporated the Newton law of gravitation. No? Now, the general relativity is a theory of gravitation which is more complete and supersedes the naive gravitational law of Isaac Newton. No? So we discover something and we have to change completely the theory. This is our Ithaca. Let's say we would be happy at the moment in which we prove that our theory are wrong. So it's actually the opposite with respect to what is the general prejudice.
Can we say that Ithaca, it's also a good question, a question asked intelligently?
Absolutely, yeah. Yeah, actually this is the real problem. We are explorers. We are curious people that try to ask ourselves new questions, but the real effort is to express them correctly. No? Because if you don't ask yourself the right question, or you express it incorrectly, you will never find the solution. So the real worry of a good scientist is to ask ourselves. I'm asking myself or my group or my collaboration the good question, the real question, and are they stated correctly, such that we could say, we could find the solutions, a yes or no, in an ambiguous solutions. This is the real effort in which we put a lot of strength.
Mm-hmm. How can we overcome the barrier to enter the, it's a quote from you, thrilling center of modern scientist research, and why you also say this, for understanding the origin of our universe, we must be willing to face a very risky journey.
This is what I was alluding before, no? The concepts that we need. So if today I explain the origin of the universe in a non-scientific audience, I'm forced to use the general language, the same language that we can use in a dinner with friends. And Genesis is written in this language. It's written in a language that can be understood by everybody, including people that hate physics, because there are, I discovered that some of the readers wrote me, I used to hate physics because I never understood anything, but if I follow your reasoning, your statements, those are understandable. So we have to remove a barrier, the specialistic barrier that we use to develop science is something that can be understood only by a very small fraction of the people. But the concept that science develops are so important for everybody, for the entire community, for the entire society, because these concepts will shape the future of everybody. In particular, in this particular moment, in this century, knowledge and science drives everything. No? We have seen the importance of science in the recent pandemic. No? In every country there were scientists talking every day in the TV. People were looking at them to find solutions. No? But this is true in general. We need science to find solutions for the ecological crisis. We need science to find solutions to reduce imbalance, injustice in the world, to reduce the difference between the rich countries and the poor. There are, whatever is the problem, we need a scientific solution first, and then we need some political and social solutions to accompany the scientific solutions. So it's a moment in which science plays an important role, a role which is unprecedented, no? And this is why everybody should know what science is doing. Everybody should be aware of where is science moving. Everybody should be conscient of the challenges and the risks that sometimes could be present. No, again, how this can be done? We cannot pretend people become specialists, but this is what I consider my duty to explain in normal words, no, where we are, what is the status of the scientific research in the world, what we have known so far, and what we don't know. And I expressing this idea, these thoughts to my community will make everybody more aware of where we are and what are the challenges of the future. A reader of Genesis will discover at the end of the book that not only he or she has understood much more of science, he or she has understood much more of himself or herself and his or her role in society.
Mm-hmm. Is the modern science a great collective adventure? Is a story about solidarity? Actually, the hidden question is, it is possible to go in modern science only on an individual road?
It's difficult because it is an interplay, actually. You know, if I look to the dimensions of the large collaborations, being the collaboration in which I'm working, for example, CMS experiment at CERN, the experiment I led the time of the discovery of the boson, is an experiment collecting more than 3,000 scientists from all over the world. And the same is true for the experiments that discover the gravitational waves. LIGO and Virgo are huge international collaborations. Or experiments that, let's say, the launch satellites like Planck, or a new telescope like the James Webb telescope. All these are international collaboration of hundreds or thousands of scientists. But say that within this large collective effort, there is always the room for individuals. Could be an old professor, could be a young student, but there is, I mean, science is challenging and is risky, and is a playground in which the one that produces new ideas, new approaches, would have the possibility to overcome all difficulties or to be able to make major discoveries. So it is an interplay, a collective effort to produce the instrument, to produce the infrastructure, and individual contributions that may change the game. No? Still today, we witnessed individual contributions that have changed radically the approach of thousands of people. So it is a continuous interplay between the collective effort and the individual contribution that might produce something completely unexpected.
Mm-hmm. You are using this formula, cosmic chaos. What is cosmic chaos? It can be also a poetic formula, isn't it?
There is, yeah. I like it because we used to use cosmos to explain as a synonym of the universe, no? Assuming that the universe is ordered, no? Cosmos means in Greek an ordered object, no? And so we have a prejudice that the entire universe is something well ordered, quiet, that looks like the corner in which we live. No, the prejudice origins from the fact that if we look to our planet, to the moon, to the solar system, to this corner of the Milky Galaxy, everything seems quiet and reasonably in equilibrium. No, looks like really a cosmos, an ordered system. No, at least it is in equilibrium since millions of years. We have no memory, no, of a chaotic environment, no. Everything seems to be smooth and regular, no. every 24 hours there is day and night, and the day and night goes one after the other. Every month the moon presents its face to the earth. Every year there are the seasons that defines the regular path of the earth around the sun. Everything seems to be ordered and calm. But as soon as we have explored other regions of the universe, if you start immediately our sun, if you take a look to our sun very closely, what seems to be a very quiet and quiet star is something really monstrous. The surface of the sun is full of convective motions, is thermonuclear reactions boiling inside. There are emission of plasma that with immense magnetic field, immense temperature of huge dimensions. So, and the same is true if we take a look, for example, to the inner core of our galaxy, where there is a huge black hole, which is called Sagittarius A, is a monster which is able to swallow stars in a fraction of a second. So the region in which the universe is turbulent, is chaotic, in which there are entire worlds which are destroyed by catastrophic events, those regions are not are very frequent. We see every day entire galaxies which are shattered, which are destroyed by what we call active galactic nuclei, which is incredibly large black holes. So the idea of having a universe which is a synonym of cosmos should be abandoned. There is a mixture of chaotic elements coupled together to order elements. This explains better the current structure of the universe, and it's also true also for the world of the let's say, if we take a look to a glass of water inside a very small distance, and also there the chaotic elements play an important role. So it looks like a chaotic nature which seen from distance in particular region looks an order nature, and that we call cosmos.
So it's better to use the oxymoron, this oxymoron.
Yeah.
What was in the beginning? How do you complete, as a scientist, this formula? In the beginning, it was ...
It was the void. This is what we have discovered, let's say, recently, in a matter of a few few decades. So it's not something which is known since a century, and it was a surprise. It was a surprise for many, including scientists, that in some sense we have discovered from where the universe originated. And the object, let's call it this way, is what we call vacuum, which is not emptiness, which is not nothing. Vacuum is a material system that we characterize in physics, is a system which has zero energy, zero mass, but is a material system, is not a philosophical concept. Is a material system that follows the laws of physics, in particular the laws of quantum mechanics. So if I take a look to the original void, if we look very closely, we see fluctuations. It's a system in which the energy cannot be zero forever, because this is forbidden by the uncertainty principle, the Heisenberg principle. So being a material system, it should fluctuate. And fluctuation means the formation of very small bubble, what we call a quantistic foam. Very small bubble that appears and disappears continuously. So we have to imagine something like this, a state of matter in which there are very small, tiny fluctuations. And in particular, in one of these tiny fluctuations, at a certain moment, extracting from the vacuum a particular material that we call inflaton, this bubble started to expand. And the funny thing, the thing that surprised everybody is that it happens spontaneously. There is no need of energy. There is no need of external intervention. It is a natural transformation of the vacuum into a universe. If you take into account energy, no? If I want to produce a very small bubble of space-time, I need negative energy. If I want to produce a very small amount of mass energy, I need positive energy. So if I put together mass energy and space-time, I don't need energy. It's zero. It's still zero. So our universe is a mixture of mass energy in a space-time structure. And the general energy of this system is zero. It's the same quantum number of vacuum. So our universe is a state of vacuum that has gone through a transformation. Modern science is able to explain these transformations, but the most astonishing thing is that we can still say our universe is basically a vacuum state.
Mm-hmm. So in the beginning was not, as we read in the Bible, was not the word.
And yeah, this is yeah. In some sense, I mean, I like this the sentence of the Bible because gives to the word, no, a creative importance. In some sense, I consider it true for humankind, no, because basically we have become human, really modern human, let's call it this way, at the moment in which we have given word to the things. No? In some sense, this sentence recalls this. No? The ancestors that first used the words to describe their life or the object they were around them, this was the moment of the creation, no? In the sense in which humankind became sensitive, became fully aware of his or her role in this scenario. So the importance of naming, of giving names to the word that the biblical sentence recalls, in some sense, recalls this historical moment in which naming things and using the words to describe the material world, the natural world, the individuals, was the real origin of humankind.
It is inevitable that modern physicists, particle physicists, are very sensitive to philosophy's topic. Maybe even to be very sensitive to poetry for the modern physicist, for the particle physicist.
They say, I know I have friends which share my same passion for art, literature, poetry, beauty in general. But to be really frank, I have also many other friends which are excellent scientists, completely let's say, they have no interest in other than science. Now you see, like people that like and love very much their profession, but they have no interest for philosophy or for art, etc. So I would not say that there is an intrinsic link between modern science and the interest for philosophy, art, and science. There is a part of scientists which, and I belong to this part, maybe because I am Italian, maybe because I went through classical studies before going to the university. In my brain, let's say, the excitement or the emotion for a new scientific theory or for a piece of opera or for a music, the brain, I cannot divide my brain in compartments. No, I feel the same emotions in different fields. But this is not true for everybody. I have a very good friend, in particular, I would say in UK and the United States, in which the formation is different. And some of them are completely, they don't care at all with respect to art, music, philosophy. They only care about physics.
Mm-hmm. The hidden question, and actually the last question of our very beautiful conversation, is this one. Do modern scientists meet the gods, discover new gods on the path of their experiments?
No, this is actually is a very clear answer to this question, because science is extremely powerful. No? Is an extremely powerful tool, just because it looks for unexpected results to change the theory. No? This attempt to falsify the previous theory is what makes science extremely powerful. No? But is powerful in exploring nature, no? In exploring natural phenomena. If you imagine something beyond nature, over nature, a supernatural entity, which is God, clearly this is an area in which science has no tool, so by definition. So the fact that we can explain in full details what is happening in nature does not imply that one has not the freedom to believe in God, to believe in something beyond nature. No? So in some sense, there are two fields separated that can live together without any conflict. No? I have friends which are Catholic or Jewish, which are extremely good scientists. They believe in God. I'm not a believer, but we share the same scientific view. Then there is a point in which the act of faith means assigning to somebody else something which is not rational, is emotional, is not something that comes from the brain, comes from the soul, the body, the spirituality. And this, at this moment, the two parts divides, but this does not prevent us to discuss together, to share the same view, and to fight the same battles. No, this is, we are not anymore, luckily, at the time of Galileo Galilei, in which the two worlds were in strong conflicts. So today, modern science that does not pretend to convince people that have a sincere belief in God, no, on the other hand, should pretend not being constrained by let's say theological reasons or by religious constraints. So we are free. We can discuss. We can identify common issue, and in this sense, is a fantastic period.
Thank you very much, Mr. Guido Tonelli, for this book, for this huge privilege to have a very, very beautiful conversation. Thank you very much.
Thanks to you. Thank you.